A compile time error occurs when you ask Python to run the application. Before Python can run the application, it must interpret the code and put it into a form that the computer can understand. A computer relies on machine code that is specific to that processor and architecture. If the instructions you write are malformed or lack needed information, Python can't perform the required conversion. It presents an error that you must fix before the application can run. Fortunately, compile time errors are the easiest to spot and fix. Because the application won't run with a compile time error in place, user never sees this error category. You fix this sort of error as you write your code. A runtime error occurs after Python compiles the code you write and the computer begins to execute it. Runtime errors come in several different types and some are harder to find than others. You know you have a runtime error when the application suddenly stops running and displays an exception dialog box, or when the user complains about erroneous output. Not all runtime errors produce an exception. Some runtime errors cause instability, errant output, or data damage. Runtime errors can affect other applications or create unforeseen damage to the platform on which the application is running. In short, runtime errors can cause you quite a bit of grief depending on precisely the kind of error you are dealing with at the time. Many runtime errors are caused by errant code. For example, you can misspell the name of a variable, preventing Python from placing information in the correct variable during execution. These are examples of errors of commission, which are specific errors associated with your code. In general, you can find these kinds of errors by using a debugger or by simply reading your code line by line to check for errors. Runtime errors can also be caused by external sources not associated with your code. For example, the user can input incorrect information that the application isn't expecting, causing an exception. A network error can make a required resource inaccessible. Sometimes even the computer hardware has a glitch that causes a non-repeatable application error. These are all examples of errors of omission, from which the application might recover if your application has error trapping code in place. It's important that you consider both kinds of runtime errors, errors of commission and omission, when building your application. Whenever you make a typo of some sort, you create a syntactical error. Some Python syntactical errors are quite easy to find because the application simply doesn't run. The interpreter may even point out the error for you by highlighting the errant code and displaying an error message. However, some syntactical errors are quite hard to find. Python is case sensitive, so you may use the wrong case for a variable in one place and find that the variable isn't quite working as you thought it would. Finding the one place where you used the wrong capitalization can be quite challenging. Most syntactical errors occur at compile time and the interpreter points them out for you. Fixing the error is made easy because the interpreter generally tells you what to fix and with considerable accuracy. Even when the interpreter doesn't find the problem, syntactical errors prevent the application from running correctly. So, any errors the interpreter doesn't find show up during the testing phase. When you create a loop that executes one too many times, you don't generally receive any sort of error information from the application. The application will happily run because it thinks that it's doing everything correctly, but that one additional loop can cause all sorts of data errors. When you create an error of this sort in your program, it's called a semantic error. Semantic errors occur because the meaning behind a series of steps used to perform a task is wrong. The result is incorrect even though the code apparently runs precisely as it should. Semantic errors are tough to find, and you sometimes need some sort of debugger to find them. Some developers don't create a division between semantic and logical errors, but they are different. A semantic error occurs when the code is essentially correct but the implementation is wrong, such as having a loop execute once too often. Logical errors occur when the developer's thinking is faulty. In many cases, this sort of error happens when the developer uses a rational or logical operator incorrectly. However, logical errors can happen in all sorts of other ways too. For example, a developer might think that the data is always stored on the local hard drive, which means that the application may behave in an unusual manner when it attempts to load data from a network drive instead. Logical errors are quite hard to fix because the problem isn't with the actual code, yet the code itself is incorrectly defined. The thought process that went into creating the code is faulty. Therefore, the developer who created the code is less likely to find it. Smart developers use a second pair of eyes to help spot logical errors. So friends, this is it for today. Today you learned when errors occur and types of error. If you don't understand something, then you already know what to do. You can tell me in the comments or contact me. You already know what you will be learning in the next video. So bye bye, see you soon.